Contemporary compound light microscopes, like the Leica DM2500, employ Kohler illumination, an elaborate illumination system that creates a perfectly defocused image of the light source to optimally illuminate the sample to be viewed. Kohler illumination is named after August Kohler, who developed the system as a graduate student at the University of Gießen. Kohler's novel approach created an evenly illuminated field of view and reduced optical glare from the light source by employing a collector lens that focused light from the light source on the front aperture of the condenser, allowing the condenser to be focused on the specimen using a field diaphragm and condenser focus control. Kohler's groundbreaking approach was published in an article titled "A New Illumination Method for Photomicrography Purposes" in the journal Zeitschrift für Wissenschaftliche Mikroskopie, or the Journal of Scientific Microscopy, in 1893. In Kohler illumination, the role of the microscope condenser lens is to collect light from the light source and concentrate it into a cone of light that evenly illuminates the specimen. In order to acquire images of the highest possible resolution and contrast, and to reduce image artifacts, it is critical that the optical light path of the microscope be properly aligned before use. If the optical light path of the microscope is misaligned, the cone of light does not evenly illuminate the specimen, and transmitted light from the specimen does not optimally fill the aperture of the objective lens. In this tutorial, you will learn the step-by-step process of Kohler illumination alignment of the Leica DM2500 microscope. Remove the protective plastic caps over the field diaphragm lens and the ocular lenses and place them on top of the microscope. Ensure that the ocular and objective lenses are clean. Turn on the power to the transmitted light source at the base of the microscope. Ensure that the condenser filter turret is in the bright field position. Ensure that the condenser aperture diaphragm is wide open. Turn the Flexicam C3 digital camera on using the switch on the lower right-hand side of the back of the camera. Turn the microscope monitor on by pressing the small toggle switch on the underside of the bottom frame straight up, and then pulling the toggle towards you. Place a slide with an appropriately stained specimen on the microscope stage. Rotate the objective lens turret, placing the objective lens you will use into the optical light path. You are now ready to begin alignment of Kohler illumination. Step 1. Focus on the sample. Step 2. Close the field diaphragm. In the field of view, you will see a small circle of light on your specimen. Step 3. Focus the condenser, making the edges of the circle of light as sharp as possible. It is possible to focus on both the edges of the field diaphragm and the specimen simultaneously, as they are in the same conjugate image planes. The result of these first 3 steps is that the cone of light, which was initially misaligned, has now been optimally aligned with respect to the sample along the z-axis. Step 4. Carefully place a pair of 3 mm hex screwdrivers into the centering screws of the condenser. Rotate the screwdrivers to center the condenser, as indicated by the position of the circle of light in the field of view. The result of step 4 is that the cone of light, which was optimally aligned along the z-axis, has now been optimally aligned with respect to the objective lens along the x and y axes. The result of steps 1 through 4 is that the cone of light is optimally aligned along all three dimensions of space. Step 5. Once the condenser has been centered, slowly open up the field diaphragm until the edges of the circle of light just disappear outside the boundary of the field of view. Opening the field diaphragm until the circle of light just fills the field of view ensures that a maximal amount of transmitted light is collected by the objective lens and exploits the full resolving power of the optical system. Alignment of the optical light path should be performed at the beginning of each microscopy session to ensure optimal imaging conditions. In addition, each time a different objective lens is used, it is necessary to adjust the Kohler illumination settings to accommodate changes in magnification and numerical aperture of the new objective lens.